So because uniform motion is so important, I would like to give a brief summary. So first, uniform motion is a model that only applies if you have motion with a constant velocity. Constant velocity means that velocity is not changing, which means that your acceleration is equal to 0. If you have acceleration that is not equal to 0, you cannot use uniform motion. Now this means that our object can be modeled as a particle moving in a straight line at a constant speed. If for any reason you can't model it that way, you cannot use uniform motion. So visually, you can look at this motion diagram. The other two visual representations we can use are a velocity versus time plot or a position versus time plot. On position versus time, we need to see a straight line where the slope tells us the speed, and on the velocity versus time plot, it needs to be a perfectly horizontal line since that represents no change in velocity whatsoever. Again, in many cases, this might be a simplification compared to what you would measure in the real world, but if you need to worry about any significant deviations from this, you shouldn't be using uniform motion. There are two equations that we largely will be focused on using in this situation, that the velocity in a direction, for instance x or y, is equal to the change in position in that direction divided by the change in time, and we can then express the position in terms of its initial position, that velocity multiplied by that change in time. So again, this model has some simplifications in it, and one of the big limitations is that if you cannot ignore acceleration, if acceleration is not 0 or almost 0, effectively 0, as if I'm trying to walk in a straight line, for instance, you can't use this model. So that's really important to know. So please, please, please be careful about that. So finally, to summarize everything covered in the video, the uniform motion is when an object is moving along a straight line at a constant speed, which we would say is no change in velocity. And we see that you get a straight line on a position versus time graph, and the slope was telling us the speed or the velocity. We'll have a horizontal line on the corresponding velocity versus time plot, and it's really important when mathematically working with this that you're careful with initial values, that you don't set things equal to 0 that are not 0, and the delta values, the change in position, the change in time, that you actually make sure you're using final minus initial there.